Hello dear students, in this class we are going to discuss concepts of relations and functions. Let's see the question. Let A is equals to 1, 2, 3, 4 and B set is 5, comma 7, comma 9. Determine A into B, Cartesian product. Okay, so A into B. A into B is equals to A set, first of all, A 1, comma 2, comma 3, comma 4 into B set is 5, comma 7, comma 9. So if I do a product 1 comma 5, 1 comma 7, 1 comma 9, 2 comma 5, 2 comma 7, 2 comma 7, 2 comma 9, 3 comma 5, 3 comma 7, 3 comma 9, 4 comma 5, 4 comma 7, 4 comma 9 is the Cartesian product of A into B. Okay, now we will write first done, completed. Now second, Cartesian product of B into A. BA, Cartesian product of two sets. So first write B, 5 comma 7 comma 9 into set A is 1 comma 2 comma 3 comma 4. Then what is the product here? 5 comma 1, 5 comma 2, 5 comma 3, 5 comma 4. Okay, 5 comma 1, 2, 3, 4. The same way 7 comma 1, 7 comma 1, 7 comma 2, 7 comma 3, 7 comma 4, and 9 comma 1, 9 comma 1, 9 comma 2, 9 comma 3, 9 comma 4. Okay, now see here A into B. So always here order pair, in order pair X is abscissa, Y is ordinate, right? So here 1 is abscissa, 5 is ordinate. So here what is asking here? A into B, we done. B into A, done. So is A into B and B into A both are same? No. Why no? Because see here B is what? B elements are range, A elements are domain. Okay, A elements are domain. A elements are domain 1 2 3 4, 1 2 1 1 1 2 3 4. Domain elements. B range elements. Okay, 5 7 9, 5 7 9. Now in this, if you see here B into A, B elements are domain, B elements are domain, A elements are range values, A elements are range values. Here 1 2 3 4, range and codomain you can say here. Next, is AB and BA both are equal? A into B is not equals to B into A, B into A. So therefore this is the third question. Fourth is n of A into n of A into B is equals to n of B into A. Number of elements in A into B is what? 1 2 3 4 5 6 7 8 9 10 11 12, right? 12. The same way 1 2 3 4, 1 2 3 3 4 is 12. So therefore here n of number of elements in A into B is 12. N of B into A is also 12. Therefore we can say fourth question, n of A into B is equals to n of B into A. Okay, this is also correct. Here we have a set A is equals to 1 comma 2. Find Cartesian product of three sets. Okay, so let us say here A into A into A. So first we will do A into A first, two sets, Cartesian product 1 comma 2 into 1 comma 2. So if I do here product 1 comma 1 comma 1 comma 2, next 2 comma 1, 2 comma 2. Okay, this is a Cartesian product of A into A. Next we have to do A into A into A. So we will do directly here A element is 1 comma 2 and A into A is 1 comma 1 1 comma 2 1 2 comma 1 2 comma 2. So 1 comma 1 comma 1 1 comma 1 comma 1 comma 1 comma 1 comma 2 1 comma 1 comma 2 1 comma 2 comma 1 1 comma 2 comma 1 1 comma 2 comma 2 1 comma 2 comma 2, and with respect to 2 we will do 2 into 1 2 into 1 into 2 comma 1 comma 1 2 comma 1 comma 2 2 comma 2 1, comma 1 2 comma 2 comma 2. Therefore these are the elements of A into A into A. We have here x comma y comma z got. Okay, if order paired x comma minus 1 and 5 comma y belongs to a set, your set is a comma b such that b is equals to 2a minus 3. Find the value of. So first we will write the given data. Given a set, a relation a comma b such that b is equals to 2a minus 3. Okay, so here x comma 1 belongs to this set. Okay, so we will substitute in the place of a x comma 1 such that minus 1 such that in the place of a x, in the place of b minus 1. So minus 1 is equals to 2x minus 3. Okay, so this is a set form. If I simplify this, 2x minus 3, send it to left side. So minus 1 plus 3, x is equals to, this is 2, this multiple, send it to right side by 2. So x is equals to 1. X is equals to 1. In the same way, 5 comma y belongs to this set. So in the place of, so I am writing 5 comma y such a way that in the place of b we have to write y is equals to 2a. A is what? A is 5. 2 5s are 10. So y is equals to 2 5s are 10 minus 3. Y is equals to 10 minus 3 is 7. Therefore we know the x and y is asking to find x and y. Therefore these are two solutions. That's it. Here we have capital A and capital B are two sets having three elements in common. If n of A is equals to 5, n of B is equals to 4, find n of A into B and n of A into B intersection B into A. So first of all we will write the given data. Okay, so given data, n of A and n of B are sets having common elements. So given n of A intersection B is equals to 3 elements. Number of common elements in A and B is 3. Next, n of A is equals to 5. N of B is equals to 4. N of A in A into B. N of A into B is equals to n of A into n of B. Okay, so n of A is what? 5. N of B 4. 5 4s are 20. So 20 elements we have in A into B. Okay, so next, what is asking here? N of A into B intersection B into A. Okay, so here is asking number of elements in A into B intersection B into A. So let us consider A intersection B. We have three elements, A and B in between we have three common elements. Let us consider A set is equals to A, B, C, D. Okay, and B set, let us consider A, B, C, D, E. We will consider this is okay. A, B, C, D, E, and we will consider here B set is A comma B comma C comma F, let us say, because three elements are common in between A and B, right? So A and B, three elements. If I do here A into B, what is the result? I need to get 20 elements, right? So let us consider 20. A comma A comma B, A comma C, A comma F. Next, B comma A, B comma B, B comma C, B comma F. Next, C comma A, C comma B, C comma C, C comma F. Next, D comma A, D comma A, D comma B, D comma C, D comma F. E, E comma A, E comma B, E comma C, E comma F. So how many we have? 1, 2, 3, 4, 5. 4, 1, 2, 3, 4, 5. 5 4 is 20. Total number of elements in A into B, 20 elements we have, right? So if we do A into B and B into A, you will have 9 elements common. You have 9 elements common because A into B we have, how many we have? A into A into B, A comma B, A comma C, B A, B B, B C, C A, C B, C C. All this common we have, common we will mark. Okay, how many we have order pairs? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements we have common. So in this A into B, 9 elements we will have. B into A is also we will have 9 elements. So 9 elements common is, intersection is common, right? So therefore 9 elements. In other words, we will write here n of A intersection B intersection, sorry, A into B, A into B intersection B into A is equals to. So in this we will have 3 elements into 3. 3 is a 9. Therefore 9 is the answer. We have a question here. Cartesian product A into A has 9 elements, among which are found -1, 0 and 0, 1. Find the set A and the remaining elements of A into A. So let's see here. N of A into A has 9 elements. Okay. Cartesian product of A into A is equals to 9. So can I write N of A into N of A is equals to 9. Can I write 3 is a 9. Therefore N of A elements have 3 elements. N of A is equals to 3 elements. Okay. N of A is 3 elements. Here A is domain, A is also range. So AA, whatever the elements in X and Y coordinate we have, those elements we have to consider A values. Now what is A here? A set we have here, A set -1, 0, -1, 0 and 1. Okay, so we have A elements is -1, A elements -1, 0, 1. So we can write A into A is equals to, so -1, 0, 1 into -1, 0, 1. So therefore we will write here Cartesian product -1, 1, -1, -1, -1, 0, -1, 1. Next 0, -1, 0, 0, 0, 1. Next 1, -1, 1, 1, 0, 1, 1. Okay, this is the A into A Cartesian product. Here we have a question. A is equals to 1, 2, 3, 14 and so on 14. Find define relation R from A to A. So relation R is defined from A to A. So this is a A set and one more is also A set. Okay, these both are A sets. A, this is A. A elements are 1, 2, 3, 4, 5, 6, 7 and so on 14. Here also A set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so A set. What is the relation is given here? Relation given, solution part, given relation So I'll write the given relation r is equals to x comma y such that 3x minus y equals to 0, where x and y belongs to capital A. Okay, so can I send y to the right side? 3x is equals to y. Again I'll rearrange and write y is equals to 3x. Y is equals to 3. If I substitute in the place of x1, if I substitute x is equals to 1, then what is y is equals to 3 into 1? 3, right? If I substitute x is equals to 1 in this, I'll get y is equals to 3. So if I select to 1, then y is 3, right? This is 3. Next, if I select x is equals to 2, then substitute in the place of x2. So 3 2s are 6, right? So 3 2s are 6. Where is the 6? Here I am mapping here. So next, 3 is a 9. 4 3 is a 12. Okay, next 5 3 is a 15. 15 is beyond of the set. Therefore we have here 1 image 3, 2 image 6, 3 image 9, 4 image 12. So we can see here relation R from A to A. So we can see here what is domain and range. What is range and domain here? See here, domain. First I'll write domain. So left side we have a domain 1, 2, 3, 4, right? This is a set 1, 2, 3, 4 is the domain. And range. What is range here? What is range? Set of 3, 6, 9, 12. 3 multiples. 3, 6, 9, 12. Okay, these are range. Next, what is codomain? Codomain, entire set of A, this side. Okay, entire set of this side. So we have 1 to 14 codomain. 1, 2, 3, 4, and so on. 14. This is the codomain. That's it. Here given A is equals to 1, 2, 3, 4, 6 and R be the relation on A defined by relation R. So here given set builder form. So R is equals to set builder form given A comma B such that A comma B such that B is exactly divisible by A. Okay, exactly divisible. B by A, exactly divisible. Okay, so exactly divisible by A, exactly divisible. So here exactly divisible. Here set A. Here A comma B belongs to capital A, right? So capital A elements what we have here 1, 2, 3, 4, 6. So we will write here. So 2 by 1. 2 by 1 is exactly divisible, right? 3 by 1 is exactly divisible such that here B is in the place of B we have 2. In the place of A 1 we have. So 1 comma 2, this is the set. Next, order pair. Next 1 comma 3 is order pair. Next 1 comma 4 is order pair, 4 by 1. Next 6, 1 comma 6 is order pair, 6 by 1, exactly divisible. Next 3 by 1, 4 by 1, 6 by 1. Next 1 comma 1. Okay, 1 comma 1 is exactly divisible by, right? So 2 comma 2 is exactly divisible. 3 comma 3 exactly divisible, 3 by 3. 4 comma 4 exactly divisible, 4 by 4. 6 comma 6 exactly divisible, right? 6 by 6. Next, what are exactly divisible? 4 by 2, right? 4 by 2 exactly divisible. 4 by 2 is exactly divisible. So we can write here 2 comma 4. Next 4 by 2. Next 6 by 3. 6 by 3. 6 by 3. So we can write here 6 by 3 exactly divisible. So we can write here 3 comma 6. Let's count. Next we have here 6 by 2. right? 6 by 2. So 6 by 2 is also exactly divisible, right? So 2 comma 6. Therefore we have, these are order pairs. So I am writing in a row star form 1 comma 2 comma 1 comma 3 comma 1 comma 4 comma 1 comma 6 comma 1 comma 1 2 comma 2 3 comma 3 4 comma 4 6 comma 6 and next 2 comma 4 3 comma 6 2 comma 6. This is the relation we have. Now we have to write here domain and range, right? Domain. So first element of order pair, right? Domain. So 1 2 3 4 6. 1 2 3 4 6. What is range? Second element of order pair. Okay, second element of what? 2 3 4 6 1 2. So domain is 1 2 3 4 6. That's it. This is the solution. Row star form, domain, range. That's all. This is the solution. Here we have a question. Find the domain of each of the following real valued functions. Now we will start the functions related questions, finding domain. Okay, first question. We have here first question. F of x is equals to 1 by x plus 2. Whenever we have in this kind of question, denominator is not equals to 0. Denominator is not equals to 0. Always if it is equals to 0, it will goes to infinity, right? So denominator is not equals to 0 in order to find the domain. Okay, so x plus 2 is not equals to 0. Send this 2 to the right side. X is not equals to minus 2. That means x is not equals to minus 2, except that it can be any number. So we can say here domain, or to find domain, x belongs to all real numbers exist except minus 2. That's it. This is the domain. Okay, next question. Next question, what we have here, f of x is equals to, second question, f of x is equals to x minus 1 by x minus 3. So what is the domain here? So denominator is not equals to 0. So denominator what we have? X minus 3 not equals to 0. Send 3 to the right side. X is not equals to 3. So we can say here domain of the given function is domain x belongs to all real numbers except 3. That's it. This is the domain of the given function. Here we have a function f of x is equals to x minus 3 by x square minus 3x plus 2. So what we will do here, denominator, whenever you see f of x by g of x form, whenever we have f of x by g of x form, function linear by quadratic or quadratic by quadratic, so make sure in this case, in order to find domain, g of x is not equals to 0. Okay, make it g of x is not equals to 0, you will get the domain. Now here denominator is not equals to 0. What is denominator here? X minus 3x plus 2 is not equals to 0. So quadratic, x square, splitting middle term, minus 2x minus x plus 2 is not equals to 0. So from here x take common, so x minus 2 minus 1 take common, x minus 2 is not equals to 0. X minus 2 x minus 2 common, then remaining is x minus 1. X minus 1 is not equals to 0. So from here we can say x minus 2 is not equals to 0, x minus 1 is not equals to 0, or x is not equals to 2, x is not equals to 1. Therefore x is not equals to 1 comma 2. We can say here domain x belongs to all real numbers except 1 comma 2. Okay, find the domain of the function f of x is equals to root x minus 2. So whenever we have a root over 0 exists, root over positive exists, root over negative does not exist. So we can write here positive means inside the root we have expression x minus 2, either it is positive means greater than 0, right? Greater than 0 means positive, 0 exists, so we will write equals to 0. So x minus 2 greater than equals to 0. If I send this 2 to the right side, x greater than equals to 2. So if I substitute in the place of x 3 greater than 2, true. 10 greater than 2, true. That means here this is a number line 2, including 2, closed interval 2, and going towards infinity. Okay, therefore we can write the if x is real number, we have to write here x belongs to 2 to infinity. 2 to infinity. If here we have a function f of x is equals root or 4 minus x square. So just now we discussed, whenever we have under the root the expression either positive means greater than 0 or equals to 0, but negative does not exist, so greater than or equals to 0. Whenever we have 4 minus x square, make sure x square coefficient positive in order to apply wavy curve method. Okay, squaring negative apply on multiply on both sides. So x square minus 4, if I multiply negative, inequality changes, less than or equals to 0. Can I write here x square minus 4, can I write 2 square less than or equals to 0? This is in the form of a square minus b square, right? A minus b into a plus b less than or equals to 0. Now draw the number line. When you will get this factor 0, x minus 2 equals 0, then x is equals to 2, right? I am writing here 2. Next, x plus 2 equals 0, x is equals to minus 2. Plot this minus 2. Okay, now 2 to infinity, select any number, 5 let us say. So 5, if I substitute 5 here, 5 minus 2 positive, 5 plus 2 positive, positive into positive, I will get the positive, I will write positive. Minus 2 to 2, select any number, 0 I will select, 0, 0, here minus 2 plus 2, minus 2 into 2, minus 4, so you are getting minus 4 ultimately, so minus. Next, if I select minus 2 to minus infinity any number, let us say minus 5, minus 5, minus 2, minus 7, minus 5 plus 2, here also minus into minus plus, therefore this is plus. So we got the signs. Now less than indicates what? This entire expression is negative, right? This entire expression is negative. So here the two factors together negative. That means here domain x belongs to minus 2 comma 2, closed interval. Why we are including closed interval? Because we are including minus 2. If I include minus 2, if I substitute minus 2 plus 2 0, so equating 0. That is the reason why we are including extreme. Okay, so that's all. This is so we have here find domain and range. Let us consider this is the first question. So first question, f of x is equals to x minus 2 by 3 minus x. So first of all we have to find domain and range. Let us say in order to find domain, I am writing domain here, domain. So in order to find domain, denominator term is not equals to 0, right? So 3 minus x is not equals to 0. Send x to the right side. 3 is not equals to x. So x is not equals to 3. That means x belongs to all real numbers except 3. Okay. So this is the domain. Next, how to find range? In order to find range, listen carefully. We have, let us say this is y. Okay. Let us say let y is equals to x minus 2 by 3 minus x. Okay, we consider the function x minus 2 by 3 minus x. So y in terms of x is there. Try to convert x in terms of y. Y is subjected to x, right? So x is subjected to y will do. Okay, so multiply this to the left side. Y into 3, 3y. 3y into x minus xy equals to x minus 2. Now separate x terms one side and remaining all terms other side. Okay, x terms one side, remaining all terms other side. So minus xy minus x is equals to plus 3y goes through right side, minus 3y minus 2. So take minus common, cancel. Okay, minus x common. Can I write here y plus 1 equals to minus common 3y plus 2. Okay, so minus cancel, send y term to the right side. X is equals to 3y plus 2 divided by y plus 1. Whenever we have linear by linear, in order to find range, so y plus 1, denominator is not equals to 0. Denominator is not equals 0. Y is not equals to minus 1. Therefore y belongs to all real numbers exist except 1, minus 1. So therefore this is the range. Here we have a question, f of x is equals to 5x plus 3 by 2 minus x, linear by linear. To find domain, okay, we will find first domain. Okay, so domain, whenever we have g of x by f of x form, linear by linear, so denominator is not equals to 0, right? So 2 minus x is not equals to 0. So send this x to the right side. So x is not equals to 2. We will write here x belongs to all real numbers except 2. Okay, minus 2. So this is the domain. Next, in order to find range, we will consider let y is equals to 5x plus 3 divided by 2 minus x. This is range. We are going to find range. Okay, so range. Now y in terms of x is there. Try to make x in terms of y. So in order to make it that, I am multiplying this factor to left side. Y into 2 minus x is equals to 5x plus 3. So multiply y into 2, y into x. So 2y minus xy is equals to 5x plus 3. Now try to write x one side, remaining all terms one side. So 2y minus 3 and minus xy, send it to right side, plus xy plus 5x. Okay, so this is 2y minus 3. Take x common in this. Take x common. X, then y plus 5, right? Y plus 5. So this factor, send it to left side. This is multiple, send it to left side denominator. By y plus 5 is equals to x. So therefore x is equals to 2y minus 3 divided by y plus 5. So what we will say here, denominator is not equals to 0. So we can write here y plus 5 is not equals to 0. So y is not equals to minus 5. Therefore range, your range by y value, right? Y is not equals to, y belongs to all real numbers except minus 5. Therefore this is the range. Here we have a function f of x is equals to 1 by root over x minus 5. So in order to find domain, first we will see here domain. So what we discussed, root over positive x is root over 0 exists, root over negative does not exist, right? So in this, the term root over denominator we have root over positive exists but 0 not exists, because 1 by 0 is infinity. Therefore we will write here x minus 5 greater than 0, because only positive exists in that, because in denominator 1 by root over positive exists, 1 by root over 0 does not exist, because 1 by 0 is infinity. So minus 5, send it to right side. X greater than 5. When we have x greater than 5, this is 5, okay, not including 5 and going towards infinity. So therefore x belongs to 5 comma infinity is the domain. Okay, this is the domain. How to find range? So let us consider let. To find range, let y is equals to 1 by root x minus 5. Y in terms of x is there. Try to make x in terms of y. Squaring on both sides. Square on both sides. So can I write here y square is equals to 1 by x minus 5. So next, send this term to the left side. X minus 5 is equals to 1 by y square. Y square, send it to right side. So next, minus 5, send it to right side. X is equals to 1 by y square plus 5. Now closely look at here, x in terms of y we converted. Now focus on y. Always y square greater than or equals to 0, but in this case if it is equals to 0 now, it will goes to infinity. 1 by 0 infinity. Therefore we will consider this greater than 0. Y square is greater than or equals to 0, but if it is equals to 0, it is going to infinity. Therefore y is greater than 0. Y belongs to 0 comma infinity. Okay, this is the range. This is the range. That's all. This is the range.